Hi and Assalamualaikum. My name is Nurul Hazli Natasha. In this video, I will show how I use flag register, offset, pointer operator, array and loop in Visual Studio 2010 for my Lab 3 task.
Okay, now I will show how to get the value for flag register using Microsoft Visual Studio 2010. First, we go start without debugging, and then we press F10, and then register will pop up. The flag register value will appear in this part, in this register part. Flag register is actually consists of overflow flag, sign flag, zero flag, carry flag, and so on. Okay, for this coding, I need to determine what is this flag for each instruction. Okay, for the first instruction, which is move AL7FH, is not affected by the flag. So I will step over to the next line, which is add AL2, and for add AL2 I will get the OF, which is overflow flag, is 1. In Microsoft Visual Studio, OF will equivalent to OV, which is stand for overflow flag. OF will get 1 for add AL2 because if we add 7F and 2, the MSB result for this operation will get 1. It is because MSB result for this operation is supposed to be 0, which is positive, but this operation we get the MSB result will get 1, so overflow will occur. Then the sign flag, which is PL, is 1 because the MSB result for this operation is 1. Then we do step over for the next line, which is sub AL5. For sub AL5, I need to identify the sign flag and the zero flag. Okay, the sign flag, I will get 0 because the MSB result for this operation is 0, and the zero flag is 0 also because the result is non-zero, so the zero flag is not set. Next, step over to the next line. For the move instruction, like I said, the move will not affect the flag register, so we step over to the add AL ActH. For add AL ActH, I need to identify the carry flag, sign flag, and overflow flag. So the carry flag for this instruction is 1 because if we add this two value, the result will get the carry 1. Next, the sign flag for this instruction is 0 because the MSB result for this operation is 0. And then the overflow flag, we will get 1. Next, for the last instruction, I need to find zero flag, carry flag, sign flag, and overflow flag. For zero flag, it will be 1. For the carry flag, sign flag, and overflow flag will get 0. Now I will show how to use PTR operator for this coding. PTR operator is basically about we want to moving the smaller value into larger destination or moving larger values into smaller destination. So for this coding I will show how PTR operator is applied. So as we can see, my bytes will hold 1 byte data and my words will hold 2 byte data because it uses words. So for the first instruction, we need to moving the smaller value into a larger destination, which is in words. So after we step over, we can know that the value for my byte now in words after moving into the X register is 2010 because we want in words, so we have to take 2 bytes of data. Next, for the second line, which is move AL by PTR word my words plus 3, we can know that the value in EAX we will get 43. It is because this instruction we need to change the larger value into smaller destination, which is we want in byte. So we want the data my words plus 3, which is 43. That's why we will get 43 in EAX register. For the last one, the instruction is move the word PTR my bytes into EAX register. So we can see in EAX register it will move all the data in my bytes into EAX register. It is because this instruction it use the words, so it will get the whole data for this my bytes because my bytes is consists of 4 bytes. Next, I will explain for question 3 in activity 2. Okay, this question is actually about to sum up all the element of Fiona array, which is consists of 5 items in words. So we will use BX register and we will increment by 2 because it use words instead of byte. Okay, for the first instruction for this coding, it will move the first byte of Fiona array, which is 90 into BX register. So if we want to know what is the value in BX register, we need to step over. So we can see that in EBX register it will hold 0058. It is because 90 is in decimal number, so if we convert into hexadecimal number we will get 0058. Next, for the second instruction, we do step over again, and for the second instruction we need to add the Fiona plus 2, which is whole value 95 with the previous one, which is 5A. As a result, we will get the answer is 00EF in EBX register. Okay, next, for add Fiona plus 4, Fiona plus 4 will whole value of 999H. It will add with the value of 00EF, so it will get the value is 0A egg. For the Fiona plus 6, it will get the value A523. And for the last question, for Fiona plus 8, it will add the value of A523 with Fiona 8, which is whole value 99A. So the result is AEBD. Okay, next I will explain for question 4 in activity 2. Okay, for question 4, it's actually it want to sum all of the item in Shrek array, which is consists of 8 duplicate item in the words. Okay, this is the coding, and this is the instruction loop, which is loop 1. For the first instruction, we need to move the offset of Shrek array into EBX register, and then we set EAX register to 0. And then for the move EAX 8, we use 8 because we want to loop the counter 8 times, because our number have 8 numbers, 8 items, so we use 8 counter loop. For the loop coding, we need to add the EBX register with EAX. This EBX register will hold the offset for each item of the array, so it will add with the EAX. Next, for the add EBX4, we need to add by 4 because this coding use dword. So in order to get the next offset for the next number, so we need to increment by 4. And then this is the loop instruction, which is we need to loop 1, and then it will decrement the counter. Now let's see what is the value of the 8 duplicate number if we sum up of all of this. For the first counter, we can get the value is 270F. It's because if we convert 999 into hexadecimal, we will get 270F, and then it will add by 4 for the offset for the Shrek in EBX register. So we can see that the value in EBX register is changed to 5004, and then it will do the looping process. So in ECX, the number of looping will decrease by 1, which we can see that it has become 7 now. Next, we do the looping process again until the counter becomes 0. Okay, now we can see that in AX register already become 0, which means it has reached at end of the count the looping process. So we can know that the answer for egg duplicate 9999, if we sum all of the number, we can get 13x7 egg. Next, for the last question in activity 2, I will explain how I get the final answer for this coding. This coding is basically about we want to add all the item in the array using looping process. So for this coding, it declare total divert to 0 and counter divert to 7. So for the first 9 instruction, it will move 0 value into EAX register. So we can see that in a EAX register, it will hold 0 value. Next, in move EAX counter, it will hold 7 value in ECX register because we have declared the counter divert equal to 7. Next, for the looping part, we will add 10h with the value in EAX register. So for the first looping, EAX register will hold the value 10. So next line, it will loop L1 and then we go back to the previous instruction, which is add EAX with 10h. So we can know that the value in EAX register is now 20. So we do step over until ECX register equal to 0. Okay, now ECX register has reached at the end of the looping process. So we can know that the total answer after we add all of the item in the array, we get 70, which is, if we convert into decimal number, we can get the answer is 112. Yeah, we can see the result in decimal number is 112.